Hello.
Good evening, Anchala Jain ma'am.
Good evening, sir. Sir,
So,
am I
ma'am,
audible?
yes, ma'am.
Yes. Actually, sir, today there is a power cut at my area. तो video on नहीं है.
It's okay, ma'am. It's okay. No
Okay.
issue. No
Yeah.
issue, ma'am.
So, sir, shall I start?
Sir, ma'am, please. Thank you.
Okay. Thank you so much, sir. Thank you, sir. So, good evening, everyone. I hope you all are now set for today. And from today itself, we are starting with the parametric tests using the R. I hope you are listening, everyone. Today
Yes, ma'am.
video. Yes, Amita, and thank you so much for the confirmation. Video I am not switching on today till the Wi-Fi work because I am connected. I have connected through the mobile, and due to the bandwidth, I'll only keep my audio on, right? And I'll share my screen so that we can start discussing the next topic of the day. Yes. So I think I shared my screen. Give me a second. Yes. Is my screen visible to everyone? Any confirmations, friend?
Yes, ma'am.
Yes. So I'm talking about, I think, chi-square test we have seen yesterday. This is a day from where we are starting with the parametric tests, right? So firstly, I'll talk about the concept of parametric test, and then today going to discuss the various kind of tests using R. So if I say parametric test, generally this comes under the inferential statistics. I have explained you the meaning of inferential statistics. That means the whenever we are interested to confirm the population parameters using the sample statistics, in that case we are talking about the inferential statistics. In that category, there are two types of tests: parametric and non-parametric. Non-parametric concept we have understood yesterday. Today I'm talking about parametric tests. So parametric tests are those tests which are based on the parameters of the parameters of the population, and also these are considering the normal distribution of the data. In statistics, usually for each and every kind of statistical test, there are certain assumptions available. So today we will see that how we can check the normality of the data, and remaining other assumptions we will see that how we are checking them, right? So in this category, firstly I'll talk about the t-test. Can any one of you tell me what is the purpose of t-test? Using t-test, what we can measure? Anyone? Yes. No responses? Okay, fine. So t-test generally we are using to find the significant mean difference. At any point of time, you are finding like you're not or I'm not audible to you, you are unable to listen me, please inform me, because as I said, I have joined today from the mobile network. Okay, so at any point you are finding it that there is some problem, please inform me. Yes, so I said t-test is we are using to find the significant mean difference. This is the purpose of t-test. Now there are variety of t-tests available in statistics. So here we will talk about the types. So in t-test, I can say there are two types. The first one is one sample t-test, and the second is two samples t-tests. Right? So one sample t-test meaning is when we compare sample mean and population mean. In that case, we are using the one sample t-test. That means we will be having only a single sample, and its mean value we will compare from the population mean value. So this way we are trying to ascertain whether the sample is representing the population or not, whether this is a part of the population or not. So this is what we are trying to conclude in the one sample t-test, right? Similarly, if I talk about two samples t-test, so here also we can bifurcate two samples t-test into the two categories, that is independent samples t-test and dependent samples t-test. So these are the two different type of t-tests available in the category of the two samples t-test. Now, first I talk about the independent samples t-test. So when I talk about independent samples t-test, I hope my voice is clear.
Yes, ma'am.
Yes. So when I talk about independent samples t-test, here you can see that we need to now, I can say we are comparing the mean of two unrelated groups. So in independent samples t-test, as you can see, name itself is saying independent. So that means two groups will be unrelated or independent. So that way you are going to compare the mean of these two groups, and then you are saying whether they both the samples are came from the same respective populations or not. So this way, this is the purpose of independent samples t-test. When I talk about independent samples t-test in this category, give me a second. Yes, when I talk about independent samples t-test, in this category, we need to have two variables. And what should be those two variables? The one variable should be the DV, that is dependent variable, and it should be available on the continuous scale or continuous variable it should be. And the second variable should be independent variable with two groups or categories or labels. Fine. So this is the basic requirement of the independent samples t-test. Similarly, if I talk about two independent samples t-tests, so in that case, here we are interested to compare the mean of two dependent groups or two related groups, right? So this is the meaning of dependent samples t-test. Once I'll tell you how to perform this, we will, I think I have written at So once I will discussing further that how to perform dependent samples t-test. There I'll explain you with the example. Firstly, I'll talk about the one sample t-test, right? So yes. Now I will talk about one sample t-test. So here, as firstly, I need to tell you the variable. The one variable is required, and it should be continuous. The continuous variable we need to have to perform one sample t-test. Now, if I talk about assumptions, so assumptions of one sample t-test is, first one says variable continuous in nature. One variable and it should be continuous in nature. Second assumption says variable should be normally distributed. And third assumption says there should be no outliers in the variable. These are the three main assumptions which you need to test before performing the one sample t. Hope it is clear. Audible because I changed my network now. Now I think I can. Hello, am I audible, friends? Wi-Fi are connected. Am I audible to everyone?
Yes, ma'am.
Yes. So now I will talk about. Give me a second. I'm again showing my screen. Yeah. So these are the three important. What I can say. The assumptions which you need to test or check before performing the one sample t-test in R. Now we will take one example. So give me a second. I'm writing my example here. I think now I can switch on my video. Fine. Now you can see here I'll talk about first example or exercise. Right. So I think IQ is a variable we all are aware about, right? So suppose I want to see whether the IQ of pupil is 100 or not, right? Generally for our layman or for a normal pupil, if I talk about IQ value, it should be minimum 100. If a person is having IQ level below 100, that means there is some problem or person will be mentally retired, right? So this way we know that average value for a human being is 100 for IQ, right? So now, if I want to test this, can anyone of you tell me what we need to do if I want to solve this problem? I want to test such kind of hypothesis. Suppose I am writing the hypothesis also. There is no significant difference in the mean IQ of sample and population. So friends, let's suppose this is my hypothesis. Can anyone of you tell me how we can check this? What type of vectors we need to create here? Anyone? I am expecting answers. Please reply. I hope I'm audible, friends. And are you listening to me? Friends, please tell me something. Are you listening? If listening, can anyone tell me? Yes? Anyone? Please give any confirmation, friends.
Yes, ma'am.
Okay, Ankita ma'am, I was asking that I have made a hypothesis for every one of you. So can any one of you tell me that how or how we can test that hypothesis now? What type of vectors we need to create? So can you please tell me?
We have to find out the mean of population and sample.
Okay, I think I have shown you or I have written the problem there, whether the IQ value is 100 in the people or not. So can you give some direction now further? Yes, ma'am.
Are you asking for a formula or
Not
something
formula.
else?
Formula will be explained by me. I think first time we are doing this using a. I am asking you further how I will move now. I think yesterday we have seen chi-square test, right? So I
Yes,
explained you using the vectors also chi-square test, and then we have seen using the data set also, that how we can import the data. So as you can see, I have written a problem. Can you guide us or can you share your uh, experience that after chi-square now how we can test that particular hypothesis which I have written?
Using data sets?
Yes. So how, if suppose data set is not available, so how I can perform or check further?
Making use of those CSV files.
Okay. Can't we create some vectors here? Satyen sir has written, ma'am, make some vector. Yes, very correct, Satyen sir. This is what I was expecting from you people. Fine. So suppose, I hope my screen is visible. Visible, friends? Okay. So now you can see here, I am talking about the IQ in the pupils, like, right? That what is the IQ or what are the IQ? Means I need to measure the IQ in a people, or I need to find or calculate, or maybe I can ask if a person is knowing. If not, there is a formula available using that IQ can be calculated, right? But if suppose I am creating one vector here using the or giving the name by IQ. So the vector is, see, I need to put some figures here, right? So suppose I have written here 102, 104, 102, 108, 105, 109, 110, 106, 102, 1, suppose 99, then 101. I think 11 I have taken, I make it 12. 104. Fine. Do I need to show you figures? Not visible? Fine, friends. Yes, please confirmation any. Are you people okay? May I proceed?
Yes, ma'am.
Yes. So we have created, means this can be your data set, suppose, in that there are 12 observations, 12 IQ values available of 12 respondents, suppose, right? Now you need to check the assumptions first. So suppose you want to check firstly the normality. As the first assumption, you can check here by your own that IQ value or the variable should be continuous. So we can say these are the numbers, and it is quite possible that the IQ value can be in the decimal point also. So that way IQ is a kind of continuous variable. Now talking about the normality of the IQ variable. So there is a function called Shapiro.test, right? Firstly, I'm writing here the hypothesis of Shapiro test. Hypothesis says variable is normally distributed. This is your variable. Fine. Now, using the Shapiro.test, you need to put the name of your variable inside this, like this, and then you need to press Control Enter. So you would be able to see we are getting these values. right? Is it okay? May I start explaining further? You got it?
Good evening, ma'am. Is it a non-parametric test or parametric? Normality?
Sorry?
Is it normality? Actually, no. Because small sample is there, we can follow t-test, no, ma'am.
Ma'am, this is a
Large
demo
sample.
only.
Okay.
Ma'am, I'm only giving a demo to you people. You can use these things on your data, right? Fine, ma'am. My purpose is only to explain you that how you can find that. And when we talk about the t-test, generally this is the notion of the people that the sample size should be less than 30, but it is not like that. Probably, I think I don't know we have discussed this thing or not. So generally, when we talk about the t-test, the main thing is that the variance or the standard deviation of sample is unknown. So from whatever population you have drawn this sample, if you are knowing the standard deviation of that population, in that case, you can apply for the Z test. If you're not knowing that, you need to apply the T test, right?
Yes.
So we are assuming, I think it is quite obvious because IQ is a variable which we can measure for each and every one of us, right? So that is why population size is very large. When I am saying this thing that I want to measure the IQ of the children who is below 5 years or something like that. In that case, maybe the population size should be small, and then I'm binding it by some reason or something. So then that case might be possible that population size will be small enough. But here the population size is large, so we are not knowing which what will be the standard deviation of the this IQ variable for the population. So that is why we have applied here the T test. This is the first thing. Second, I think I'm only giving the demo. So that is why I'm not considering the large data set. If you are having that data set, I have already explained you how to bring that data in the environment of R. You can import the data using the read.csv or using the read.excel. I will show you one more way today, if possible, if time permits. If not, we will see tomorrow also, right? So that way you can bring your data in the R environment, and that way you can apply these type of tests on that. Is it clear, Nangmani ma'am?
Okay, ma'am.
Yeah. So now I will talk about the Shapiro test. The Shapiro test W, generally represented by W. This is the calculated value of the Shapiro test, and its p value is 0.7172, which is clearly visible, which is greater than 0.05. If this is greater than your level of significance, in that case, can anyone tell me what will be our decision here?
H0 is accepted.
Are we accepting the hypothesis or rejecting it?
Accepting H0.
Very correct. Thank you so much, ma'am. We will accept H0 and we'll conclude that variable is normally distributed. So this is the second, this is the first way of checking the normality. Second way of checking the normality is QQ norm, and you can apply here IQ. So this method, this was the first method, and now this is the second method, QQ norm. This will make a diagram for you. Normal QQ plot diagram will be made for us by the R. So I'm pressing Control Enter. I think you can see, visible to everyone. I hope visible, friends.
Yes, ma'am.
I don't know why there is a warning. You please perform on your R script. Are you getting this? It is showing me, but it is not applying here. In your case, it is allowing you to do these colors, these circles in the red color. Anyone? Anyone who is getting colors? Any answers? Fine. So I think you can see this way you can create normal QQ plot. And if I think there is a function called AB line and you can use I. What is the problem? Anyone please perform this? I think I don't know why it is not taking in my case. You please check line number 607 is performing in your case or not. And please give any nodding or say any confirmation, any response so that I can understand are you getting it or not. Anyone?
Line is showing an error, ma'am.
Just a minute. Meanwhile, I'm copying and pasting in the chat also. So that QQ norm I'm putting in the chat box. Otherwise, at the end of the day, it is very cumbersome to copy and paste. I hope you got it. Right now, further I come and we'll check. So try with QQ line whether it is coming or not. In place of AB, you please write QQ. Yeah, it is working. Right? You can see now almost all the data points are following this fitted line. Right? Clear to everyone?
Screen is not visible.
Sorry, just a minute. Just a minute. Again, I'm sharing. I think I touched that. Yeah, it is visible now.
No, ma'am.
Your
Not
screen is
visible.
not visible, ma'am. Screen is
Not
not.
visible.
Not visible. Just a minute. Now, it's visible
Yes.
or not? Yes. Now I think you can try QQ line. I think this will work. This is the QQ line. We have fitted the best. This is known as the best fitted line. And you can see almost all the data points are following your line except the one data point. Right? Clear? So again, using the QQ plot, we can draw a conclusion that the variable IQ is normally distributed. Fine. But when there is so much deviation in these data points, in that case, you can draw the conclusion that your variable is not normally distributed. It is clear? May I proceed further?
Yes.
Yes. So I think what two things we have checked. We have checked the continuous variable nature and not. Now we will talk about the outliers, right? So I'm writing here outliers detection. So I hope you have heard the concept of box plot. Generally, box plot is having certain elements, right? These elements are the median, quartile 1, quartile 3, upper whisker, and lower. So these are the component of the box plot. Using that, you need to see that whether your variable is showing any outlier or not. So you need to use a function called box plot and pass the name of your variable, and then you can press the control enter. I hope it is visible to you. I don't know why my color is not taken by this. You please check color is coming or not. Heading is coming, title is coming. You please check everyone. Are you getting it or not?
No, ma'am, color is not coming.
I don't know why it is not coming, but it takes. We'll need to check. I'll check what is the problem. Other because tomorrow also we will running the box plot. I will try to find the problem. Okay, fine. So now you need to see the interpretation of the box plot. Here you can see the middle line. So the middle line of the box plot, this line is known as the median value. This upper line of the box is the quartile 3. This lower line of the box is quartile 1. And this area is known as upper whisker and this area is known as lower whisker. So if any of the circles are coming beyond these whiskers, maybe above the upper whisker or maybe the below the lower whisker. If you are getting any of these circles, that way it indicates that your data or variable is having some outliers. But here you can see nothing we are getting either side of the whisker. So that means we can say this thing that there is no outlier available in the data. Is it okay? I think we checked all the assumptions. Can I proceed?
Okay, ma'am.
Yes. So further, you need to use the function t.test to perform t-test. At the first position, you need to pass the name of your variable for that you want to check, or that means whatever is your sample variable that you need to pass here. Then you need to give the mu value. Can anyone tell me what will be the mu value here? Mu is the population mean.
100.
100. Very correct. It is 100. And then there is alternative parameter available where you need to write two. I need to check whether it is 2.tail or 2 tail. I need to check this. So first I'm running and then we will see. Only two we need to write. Two-sided we need to write. Two dot sided, sorry. Fine. We are getting the output. Clear to everyone? I hope you got the output. So for two-tailed test, you need to write two-sided. For the lower tail, that is the left tail, you will write less. For the upper tail, that is the right tail, you need to write greater. So these are the things you need to write. So I think it is okay for everyone. May I start explaining the output? Yes. Any confirmation, friends? Any confirmations? I hope you people have performed.
Yes.
May I start explaining? Yes. Start explaining the output? Yes. So you can see in the output you are getting the T value, which is 6.0528 degrees of freedom. That is n minus 1. It is 9. P value is 0.0001898. So you can see it is telling an alternative hypothesis true mean is not equal to 100, right? Because your P value is less than 0.05, which means you cannot accept your null hypothesis. So that way you need to go for the alternative hypothesis. And what will be the conclusion of the alternative hypothesis? I think I made hypothesis. No? Yes. This is the hypothesis. So what conclusion you will draw? If we are not accepting the null hypothesis, conclusion will be that there is a significant difference. Yes or no? There is significant difference in the mean IQ of sample and population, right? So you need to see what is the mean value of your sample, right? So you can find mean of X is 109.6. So our sample mean is coming as 109.6 and the population mean says it is 100, right? So it is quite obvious that sample mean is greater than population mean. Is it okay? Clear to everyone?
Yes.
Yes.
Clear,
Not
madam. Clear.
Ma'am, do these values change from system to system?
not getting me. Can you please repeat?
The output which I have got is different from the output which you have got.
Okay. So have you taken the same figures?
Yeah, same figures.
Let me check just a minute. Can you share your screen? Possible for you?
Just wait, ma'am.
So if you say I'll stop share my screen, as you see.
Shall I send you the data?
Data means
Whatever I have considered, whatever I have entered, the output which I have got.
you can copy and paste in the chat if it is possible. It is possible for you to share here in a chat.
Yeah, sure.
Yeah.
Same result, madam.
Sorry.
Same result. I got same result.
Okay, that's great, sir. Fine. Ma'am, are you sharing?
Yeah, ma'am, I sent you the data and I am sending you the input which I have given.
Okay. So I'm stop sharing my screen. I'm switching and checking what you have entered and what I have entered. Give me a second.
What you have entered and I have entered is same, ma'am.
Okay, 100 and just try. Yes, data is same. Fine. Are you getting what? Are you getting 4.426? And I was getting your mean value and my mean value is different, right? Oh, sorry,
Yes.
your T value and my T value is different. And mean is also different. It is all because of your mean value. Do one thing, ma'am. The vector you have created, IQ vector, na? So please check its mean. calculate, apply the mean function on IQ and please check what mean value you are getting for IQ vector. Are you getting similar or different?
The same one which I have got in this output, 104.3333.
And still I'm getting 109.6. I'm getting the same results. Okay. Is it possible for you to share your screen?
Yeah, sure.
Yeah. Now I'm getting the same results like you. I don't know what mistake I made previously, because I'm even convinced now, because my degrees of freedom was not correct previously. You can check my degrees of freedom is I think 9. It should be 11. So I think Swati ma'am, your output is correct. No issues. Right, Swati ma'am?
Okay, ma'am.
Yeah. So even I'll share my screen. I'll show you. Even I'm getting the same now. Once again I have applied it. So may I share my screen? I will stop sharing.
Yes, sure.
Yeah. I hope you can see my screen now. Visible? So
Yes, madam. Visible. Visible,
yes,
madam.
yes, sir. Thank you. So what I did, I have run this line IQ vector line again. So, sir, I think Javed sir, I don't know who was that. Venkat sir, I think. Venkat sir, you please again run this line. I think you are also getting the results like mine. So please run this line and then run this line, t-test line. So you can see now I am also getting the same results, because even I am once I have observed my output, I have got the degrees of freedom as 9. So might be possible some of the data points were not read previously. There is some problem. So now it is n minus 1. It is 12 minus 1. So I think there are total 12 observations, right?
Good, madam.
Yeah. So it should be degrees of freedom should be 11. So now I think outputs are correct. And p value is again less than 0.05. So the conclusion will remain same. We will conclude that there is a significant difference in the mean IQ of sample and population. I hope it is clear to everyone. May I proceed with the next test now?
Yes, ma'am.
Sure.
Now we will talk about independent samples t-test, right? So in that case, I already explained you, we need to have two variables, one categorical with the two groups or two labels, and one continuous scale variable. So suppose here my dilemma is I am a academician. So suppose my problem is I want to check whether the mean marks of male and female students are same. This is what I need to check. So here in that case, how many vectors I need to create?
2.
Very good. Which two, ma'am?
1 for male marks, 1 for female marks.
Very correct. So I'll write here, there is no significant difference in the mean marks of male and female students, right? This will be my hypothesis. Now I'll talk about, as it is quite clear, we need to have two vectors. So two vectors will be one for marks and second for gender, right? So I'm making my first vector, that will be a character vector. And I think if you can recall, I have told you this thing, if we are talking about the categorical variable, we need to make it as a factor. So I'm using the factor function here now, right? Now I am writing, suppose M F okay. Okay. I think a ref function also I can use, yes or no? One, two, three. One, two, three. What is the problem? Extra. This is for this. Then okay, I need to keep only two. Just a minute. Yes. Is it okay? Fine, friends. Right? I hope visible to clear to everyone what I did here. I created a factor and I want to create a factor for gender. In that I want to keep two categories, male and female. So I use the application repeated function, miss application function I used here. In that I have used concatenation function for this M and F. And then I written each equals to 22. I want to repeat M 20 times and F 20 times. So that's why I'm having total 20 students in my gender vector or factor vector. Clear to everyone what I did here? Any doubt? May I proceed? Any confirmations? Friends, please confirm. Shall I proceed? Are you getting what I have performed?
You can proceed, ma'am.
Yeah. Now you need to enter marks. So suppose the test which we have taken, it is from of 20 marks, suppose, right? So I am writing few, I need to enter 40 figures here, right? Please wait, I'll just type and I'll paste this there in a chat box so that you will also take the same figures. And that way we will get the same value, right? So please wait. How many I have taken? 2. I need to check its length. I hope you're understanding the purpose why I'm checking the length. Yes. Okay, in a chat, I copied and pasted for you. If you want, you can take the same figure. If not, arbitrary, if you want to take some other values that you can take. I have pasted in a chat. Fine. Fine. Any confirmations? So first assumption says IV should be categorical with 2 labels or groups, and DV should be continuous. This is the first assumption. Second assumption says DV should be normally distributed corresponding to the categories of IV. Then third says there should be no outliers in DV corresponding to the categories of IV. Last says there should be homogeneity of variance in DV corresponding to the categories of IV. Clear to everyone? These are the 4 assumptions which you need to check, right? So I think first 2 you can check or observe by your own using or looking at your data, whether you are having the one independent variable with 2 labels or not, and whether you are having the dependent variable, which is, sorry, first you can check the dependent variable which should be continuous. So I think we can say this thing, we are having categorical variable, in that we are having the 2 labels or 2 categories, and we are having the marks variable which is a continuous scale variable, right? Fine. We'll go for the next now. We will check the normality. So we already know using the Shapiro dot test, you need to check the normality. Now, inside this, I am passing the name. Can anyone tell me for which variable I am going to check the normality? Yes, anyone? So this time you need to see, you need to write the dependent variable first and using the tilde sign. Tilde sign will be available, I think, at the second row, first key of your keyboard. Before 1, you need to use shift key to use this. This is known as tilde sign. You can press Control Enter. What is the problem? Marks is not numeric. Sorry. Fine, it is clear. We will not use here the tilts and we will use tilts and further. But I think previously on 5, everyone, you please try whether it is working in your case or not. Tilts and gender. Please
Not
check.
working. Not working.
Same error are you getting?
Yes.
Okay, but I think it should work. What error we are getting?
I think one is numeric, one is character. That's why it is giving an error. We
No,
need
it's not like that, man. We'll do one thing. I think it is a factor vector. That is why it is creating a problem. Let me check this time. I think this time I'm creating gender like this, right? Or either we need to code the data. This can also be a problem. We'll check just a minute. Problem is, I think we need to code our data. This is the problem. Just a minute. I'll try to resolve it like this. We'll do one thing. It should be numeric now. Okay, I'll fix it because I think we need to check in both the categories of the categorical variable whether the marks is normally distributed in male category also and in female category also. But here it is not taking. So I'll try to fix it. You can go with the marks only now presently, and then tomorrow in ANOVA I'll try to find it fix the problem, right? You go with this. So you can see we are getting the value of W as 0.959 and the P value is 0.1557, which is greater than 0.05. So can anyone tell me whether I can conclude marks is normally distributed or not? Anyone? Yes. Yes, I'm waiting. I think it's. Do I need to only speak? I hope people are not interested to talk. Okay, fine. So I'm writing here. copying this. So this way I think it will save my time as well. Okay. So I have written this. It is quite clear that this value is greater than 0.05. That means we are going to accept the H0, and that way we can conclude that the variable marks is normally distributed. Further, I'll talk about the outliers checking. So you need to go for plotting the box plot for the same, and that way I am writing here the marks. Although gender is not working, otherwise you need to use a tilde sign here and then you need to see, but I don't know why it is not working, so we'll go with this only and we will do this. So that way you can see in across both the whiskers, means above both the whiskers or below first whisker and second whisker, we are not getting any circles. That means no outliers is present here. Now we will talk about the next thing, that is the homogeneity or variance. So for this, you need to use the Levin test, right? Levin test is a test which is available in the package called CARE package. So you need to install the CARE package first. I think in mine it is already installed. So I am only writing the name for you. Now you can press Control Enter. Oh, I forgot. I think it is already installed in mine, but it's still okay. It is updated. Now, after that, you need to go to the library and you need to write the name of the package, that is CARE. Done. So this way you have called this function. Now you need to use the Levin dot test. Right? Inside this, you will pass the marks and gender. I think you need to pass. There is no problem. There is no way. Fine. It is telling us to use this function. So you can see we are getting the results. Degrees of freedom 1, Levin test value is 0.1006 and the p value is greater than 0.05, right? So this is your f value. And this is your p value, which is greater than 0.05. If it is greater than 0.05, that means we are going to accept the null hypothesis of Levin test, which says that variance is equal. Right? So that means all the assumptions we have checked, and you can see in here it is working properly. There is no problem. I don't know why it is not taking in the previous two cases. Fine. I think I'll try here if it works. Yeah, it is working here. You can find this is what I was expecting. So that way you can see check here for both the categories 1 and 2. We are getting the two box plots, and this is for the male, this is for the female. So that way you can check there is no outliers available in both the categories for the marks. Right? Fine. Levin test also is saying that the variance is equal. Is it okay? Now we will proceed further to perform t-test. So I think I am explaining you. If people are not interested to stop. So that is why I am just doing or performing the test, right? So you need to write t.test using a bracket. Now you need to pass the name of your dependent variable first. Use a tilde sign. Then write the name of the second variable, which is your independent, that is gender, and you can press Control Enter. You will get the output. So output says here, this is your t value. So I'm copying this. You can find this says this p value is again greater than 0.05. So that means, just a minute. So now you can see the p value is greater than 0.05. So that means we are going to accept the null hypothesis, and we can conclude that there is a significant mean difference. It was correct previously, just a minute. There is no significant difference in the mean marks of the male and female students. That means almost marks are similar. Now you can see the mean differences also. For group 1, it is coming 13.45. For next group, it is coming 11.95, right? So I hope you have seen what I performed here. You can see these are the differences in the mean. So these differences is not significant. That is why we can conclude this thing that there is no significant difference in the mean marks because the p-value is greater than 0.05. So this way you can perform independent samples t-test. Now we will talk about the next test, that is the paired samples t-test, right? So in case of paired samples t-test, as I have told you, in case of paired sample t-test, we will be having the related groups. Groups should be related to each other, right? So in that case, what you need to do means what type of means generally this paired sample t-test is used in case of the experimental studies. Say for example, if I want to introduce some new pedagogy, right? So suppose I have, or maybe I want to introduce some new test or new software to my students, right? So before that, I want to check what is the knowledge level of my students. So that way, I have given one test to them, and I am recording their scores. And after teaching them, I have again circulated the same test and recorded their score. So in that case, you can see the group is related or dependent, because in the first conduct, suppose 60 students were there. In the second conduct also, same 60 students should be available there. So this way, this is known as the paired samples t-test for the two related groups, right? So suppose here there is a company which is offering a diet program, and company is saying that this diet program is effective and will reduce the weight of the people, right? So suppose I am saying this thing, or I'm making my hypothesis that there is no significant difference in the mean weight before and after the diet plan, right? So I am assuming that there is no significant difference in the mean weight before and after the diet plan. Now for testing this, you need to firstly know the assumptions of t-test, that is paired samples. The first is variable should be continuous. Second, variable should be normally distributed. Variable, not variable, the difference here. It is not variable, the difference. Should be normally distributed. And the last one is there should be no outliers in the difference. Difference meaning, as we are taking before and after, so we are talking about here the weight. Before a diet plan, what is the weight? After diet plan, what is the weight, right? So the difference of the weight you are talking about, so that difference you need to check whether it is normally distributed or not, or whether in that difference there is any outliers available or not, right? Now for this, I am pairing the two vectors here, right? So certain figures, suppose I need to take here, I am taking the weight values here. So I copied and pasted in chat for you people if you want to take the same values. Now I am making for the after. So I have kept it both the vectors in the chat. You can see the values from there, and if you want to copy paste, you can copy paste from there. So this way I created two vectors before and after. Now I want to calculate the difference first. So difference will be after minus before, right? So this is stored here. Now I want to check the normality of this. So for that, you need to go to the Shapiro.test. That you need to write the main difference control entry. Now you can find the p value is greater than 0.05 here. It is greater than 0.05. That means you can say this thing that your variable or the difference is normally distributed. Similarly, if you want to draw a QQ norm, you can do in this function. You can see the graph, right? Then you can fit the QQ line on the difference. Then we will go and check the outliers. So for that, you need to use the box plot. Inside that, you need to write the difference, and then you can press. So now you can see no outliers is coming in either side of the whisker. So this way, you have checked all the assumptions of the paired samples t-test. Now you need to perform the t-test. So here you need to write the before, filled, after, and you need to write paired. I think it is paired equals to 2. Just a minute. I need to check using the question mark. It is t.test function. So how it works, we will check here. It is paired. Why it is not taking then? Oh yes, that is right. You need to do. I made a mistake. You need to write here a comma. Yes. So now you can see we are getting the output here. I hope these are the values visible to all of you. And I'm copying and pasting it. So now you can see this p value is less than 0.05. This is a very small figure, right? So that way you are going to reject your null hypothesis. If you are rejecting your null hypothesis, that means what you are concluding? You are concluding that there is a significant difference in the mean weight before and after the diet plan. So now whether the plan is effective or not, that you can check, come down, you can check the mean difference is coming positive. It is 4.928, right? So that way, or you can do one thing, you can come and check the mean of before, and you can come and check the mean of after. Now you can see before before the average weight is 90.85. Before taking the right plan, weight is this. After taking the right plan, weight is this. That means your weight has reduced, or the people common weight, total mean weight has reduced, right? So that way, can we say that the right plan is effective? We can say that is effective, right? So this way you can perform the t-test. All the three types of t-tests I explained you, that how you can perform in the R environment. So I think this is all from my side for the day. If you have any queries, now the platform is open. Do you want any queries, friends? No queries?
In the last t-test, you have the last thing that we have done, you have written paired is equals to true. So that means we are talking about the independent t-tests before and after of the same people, right? But what happens when we are taking different values, for example, the population of one state and the other? So the numbers will vary.
I'm not getting your question, ma'am.
Ma'am, I'm asking that, for example, in independent t-test, you have taken the before and we have taken before and after weight of the same set of people.
I think I haven't talked about paired here. I think we are talking about the paired samples.
Okay.
Independent, previously we have discussed. In case of independent, there is no role of before and after, because when you are pairing the things, because in the paired sample t-test you need to pair your groups. So same group will be appear twice. Because I think if I'm selling a diet plan to a people, so it is quite obvious that I will check for them only that whether their weight has reduced or not. If I'm offering any training to the people, if it is impactful or not, so that way I will check for those people to whom I have given that training.
Yes.
I think this was your question, right, Harshita ma'am?
Yes, ma'am. But only thing I was asking that what happens when we are taking two different sets? So in that case, what
Two
test?
different sets means?
Two different sets. For example, if we are considering the population of two states and doing some analysis, or some different two population altogether.
That will be a case of independent samples, ma'am. Here we are, because I think I already explained, here we are talking about the related samples. If you're talking about the different, if you want to compare the literacy, mean literacy rate in two states, then that will be a case of the independent sample status.
Okay.
If you want to compare the GDP of two countries, that will be a case of independent sample status. Right? Okay, fine. I think any other questions, friends, if you are having, please unmute and ask. No queries? So can we call off a meeting for a day? I hope you people are there in the meeting and listening to me. If listening to me, please give any confirmations, any responses, whether we can end up a meeting or not. Yes.
No doubts, madam. Thank you very much.
Thank you so much, Sir Venkat sir. So
Thank you so
I
much.
think Yogra sir, over to you. We are done for the day. The session is over. We will meet tomorrow, everyone. Tomorrow is Sunday, although, but we are having the session tomorrow. We will talk about ANOVA tomorrow, right? So that is all from my side. Good night to everyone. We will meet tomorrow.
Madam,
Have a great day.
please post on the chat box, madam. Whatever the you have,
Sorry.
whatever the you taught today, please post on chat box, madam.
I'm not getting Venkat sir.
You have explained everything,
I was
madam.
asking to
The
post
syntax coding.
is- Okay.
I understand, madam. Please.
Okay. So I think till about point I have copied and pasted in a chat.
Yes, madam.
Um, okay. I think I have copied and pasted for the one sample t-test. Complete thing I have sent to you people, right?
Yes, madam.
Yeah. Further I need to talk about independent samples. Just a minute. I hope you are able to copy and paste, right, sir?
Yes, madam.
Yes. Just a minute.
Thank you very much, madam.
Just a minute. I'm copying, pasting more. This is the complete independent sample status, sir. Right?
Yes, madam.
Before and after. Now that is paired samples. Now I'm giving to you. Yes. Done.
Thank you very much, madam. Thank you very much.
So much, sir. I hope you have copied completely.
Yes, madam.
Yes. Thank you so much, sir. So thank you all. Good night. We will meet tomorrow for the second last session, right? I think it's the second last. No, third last. Yes. So over to you, Yogaraj sir. Are you there? Yogaraj sir, are you there? So shall we call off the meeting? Anyone from RFI? Ajay sir? I think friends, I'm leaving the meeting. Probably Yogaraj sir may be not in the meeting or maybe busy in some call or something. So I'm leaving the meeting. Hope to meet you tomorrow. Good night, everyone.
Good night, madam.